Bismillah ar-Rahman ar-Rahim. Hello my dear students, how are you? I hope you are fine and enjoy good time and good health. Today inshallah we will resume talking about mathematics of finance with simple interest, chapter number 3, equations of value. We will use equations for the amount is equal b times 1 plus rt, and we will use the equation of present value where is b equal s over 1 plus rt. Exercise number 1. A person owes $600 due in 3 months and $900 due in 6 months. If money is worth 16%, what single payment in 6 months will settle both obligations? Put the focal date at 6 months. At the beginning, we must know that there are 3 cases for equations of value. The first case, when the focal date lies after the maturity dates of old and new obligations, then the amount of old obligations must be equal to the amount of new obligations. The second case, when the focal date lies before the maturity dates of old and new obligations, then the present value of old obligations must be equal to the present value of new obligations. The last case, when the focal date lies in between the maturity dates of old and new obligations, then the amount of sum of old obligations plus the present value of the others, all of these equal to the amount of sum of new obligations plus the present value of the others. Note that you must draw the exercise or the problem to solve it. In our example, a person owes with $600 due in 3 months. The first old obligations equal to $600, and the second $900 due in 6 months. He need to get a single payment deserved after 6 months that settle both obligations. Look at the timeline. The first obligation, $600 after 3 months. 1, 2, 3. We count the distance, not the point. The second obligation after 6 months. We will replace them with a single payment, X, after 6 months. The old obligations under the timeline. The new obligations is in opposite, above the timeline. The left hand side, old obligations. The right hand side, new obligations. Note that to get the value of $600, we must get it after 6 months. So we will substituting in the formula of S equal B times 1 plus RT. For B with $600, for R with 16%, and for T 3 months. Note that the 3 months is the distance between the maturity date of 600 and the focal date. 1, 2, 3. And the time for $900 equal to 0, because the distance between the maturity date of $900 and the focal date equals 0. Also, the time for X equal to 0. In general, the old obligations use amount formula. where is value of old obligations equal to the value of new obligations, and where is the focal date lies after the maturity dates of old and the new obligations, then the amount of old obligations equal to the amount of new obligations. We will use the formula of S is equal B times 1 plus RT for the old obligations. Also, the amount of new obligations is equal B times 1 plus RT for new obligations. And to get X, new obligations, the value of new equal to the value of old. $600 times 1 plus 16% times 3 over 12 plus $900. So X equal $1,524. Another example. A person owes $400 due in 6 months and $750 due in 1 year. What cash payment will retire both debts if money is worth 15% used now as the focal date? The first exercise, the focal date lies after the maturity dates of old and new obligations. In this example, the required here used now as a focal date to get the cash payment will retire both debts. We know that the value of all the debts equal to the value of new debts. We must draw the timeline. The old obligations under the timeline, $400 and $750 under the timeline, $400 after 6 months from the beginning, $750 after 1 year or after 12 months. We need to replace them with a single payment X now. We need to replace the old obligations with a cash payment now. He asked to put the focal date now, so we will get the present value for $400. Also, we will get the present value for $750. The time for $400, the first obligation, equal to 6 months because it's the distance between the maturity dates and the focal date. Also, the time for the second old obligations equal to 1 year. The distance between the maturity date of 750 and now, with a rate of 15%. Note that we will take X as its value, which is equal X, because the time between the maturity date of X and the focal date equal to 0. So the amount will be equal 0, or the present value will be equal, the amount will be equal X and the present value will be equal X. Where is value of all the debts equal to value of new debts, and where is the focal date lies before the maturity dates of old and the new obligations, then the present value of old obligations equal to the present value of new obligations. Let's start with the old obligations. To get the present value of $400, we will use the formula of B equal S over 1 plus RT, where is B equal, where is S equal $400 and R equal 15% and T equal 6 months. So we will divide 6 over 12 to get it in years plus, and for the second old obligations 750, also we will get the present value. We will substituting for S with 750 and for R with 15% and for T with 1 year. At last X will be equal $1,024.267. This is the second exercise. Let's try with the third exercise. Debts of $1,000 and $3,000 are due in 3 and 6 months respectively. He needs to replace these old obligations with a cash settlement. What cash settlement will settle these debts if it is based on an interest rate of 10%, and the time of the cash settlement is used for the focal date. In this exercise, we have 2 old obligations. We need to replace them with 1 new obligation. It deserves now because we need to get the cash settlement will replace these old obligations or these old debts with a rate of 10%, and the focal date is now. The focal date at the time of the cash settlement. This is the second case of equations of value, where the focal date lies before the maturity dates of old and new obligations. In this case, the present value of old obligations must be equal to the present value of new obligations. This is the timeline. You must draw the timeline to solve this problem or this kind of problems. Look at these 1,000 and 3,000 after 3 and 6 respectively. 1,000, the old obligations. 1,000, 3,000 after 3 and 6 months. You need to replace these old obligations with 1 new obligation with a cash payment deserved now, and the focal date now. So in this time, where the focal date lies in before the maturity dates of old and new obligations, and where is the value of old obligations equal to the value of new obligations at focal date, then the present value of old obligations must be equal to the present value of new obligations. We will substituting for the first old obligations in a formula of B equal S over 1 plus RT, and for S with a 1,000 and for R with a 10% and for T with 3 months. So T will be equal 3 over 12. The second obligation, the second old obligation, $3,000. We will substituting for S with $3,000 and for R with 10% and for T with 6 months. Again, to calculate the time for any of old or new obligations, we must get the distance between the obligation and the focal date. So the distance for 1000 equals 3 months. The distance for 3000 equal to 6 months. The distance for x equal to 0. So if you need to get the present value of x, the present value will be equal x. If you need to get the amount of x, the amount will be equal to x. In our problem, the present value of $1,000 plus the present value of $3,000 will be equal to x. In this slide, according to the position of focal date lies before the maturity dates, and where the value of all the debts equal to the value of new debts, so x will be equal 1000 over 1 plus 10% times 3 over 12 plus 3000 over 1 plus 10% times 6 over 12. X here will be equal $3,832.751. Let's take a quick revision for these problems again. The first exercise, look at the timeline. The focal date lies after the maturity dates. In this case, the amount of old obligations equal to the amount of new obligations. Again, the focal date lies after the maturity dates, or the obligations of old and the new obligations lies before the focal date. In this case, the value of old, the left hand side value of old, the right hand side value of new. Value of old obligations equal to value of new obligations. Old obligations under the timeline, new obligations above the timeline. For the second exercise, we have two debts, 400 and 750, deserve after 6 and 1 year respectively. We need to replace them with a cash payment deserved now. The timeline, the old obligations, there are two old obligations, 400 and 750 under the timeline. We will replace them with X, with a single payment deserved now. Note that if the focal date lies before the maturity dates, then the present value of old obligations equal to the present value for the new obligations. And we take X as its value equal to X because of the time of X equal to 0. The payment of X equal to the value of X at focal date, because if you need to get the present value of X, you will replace the time with 0. So B will be equal S over 1 plus R times 0. So the present value will be equal to S over 1 plus R times 0 equal S over 1. So B will be equal to S. S here equal X, so B will be equal to X. Also, if you need to get the amount of X, S times S equal B times 1 plus RT. We will replace B with X times 1 plus R times 0. So S will be equal B times 1. S will be equal B. Replace B with X. So S will be equal X. In this example, we will replace the old obligations, 400 and 750, the value of them, with a single payment deserved at the date of focal date now. We use the present value equations to get the value of X. Example number 3. In this example, we have also two debts, 1,000 and 3,000, deserved after 3 months and 6 months respectively, with a rate of 10%. Replace them with X. We know that the focal date lies before the maturity dates of old and the new obligations, or we can say that equations like as, where is the old and the new dates lies after the focal date, then the present value of all the obligations equal to the present value of new obligations. Note that the time for $1,000, it's a distance between the maturity date of 1,000 and the focal date. In this example, the time for the old obligations, 1, 2, 3 equal to 3 months. To get 18 years, 3 over 12. The time for the second old obligations equal to 6 months. To get 18 years, equal 6 over 12. And the time for X equals 0. To solve this problem, the value of old obligations or the value of old debts equal to the value of new debts. So then X will be equal 1,000 over 1 plus 10% times 3 over 12 plus 3,000 over 1 plus 10% times 6 over 12. The value of X equal to the value of 1,000 plus the value of 3,000. Thank you for watching. See you next time.